Hello everyone. Today we are going to discuss about a important topic, that is our introduction topic in the chapter motion on a straight line. So my first question before even beginning this thing, my first question to you is what is called a position? Everyone is slightly confused. Is position same as a displacement? Displacement same as a distance? The thing is that many of the students and many of the teachers are thinking like position is same as displacement. It is not. Position is a entirely different quantity. Displacement is a entirely different quantity. Distance is a entirely different quantity. Once you see the difference between these three quantities, the chapter becomes very easy. So let us first dive into the topic what is called position and what is called frame of reference. If you want to study what is a frame of reference, you should first know what is called position. So without further wasting time, let us start into position. So what is the meaning of the term position? Let us see. Position, that is what we are going to study. Position, in physics we represent everything by some letters. I know pressure is represented by P, velocity is represented by V, force is represented by F. We know all these quantity. How positions are represented? Very simple. Positions are represented by three options. Either you can represent the position by X, or you can represent the position by Y, or you can represent the position by Z. See, now you understood what is position. It is basically X coordinate, Y coordinate, Z coordinate. It is neither distance nor displacement. It is simply where the particle located with respect to origin. So the definition is very simple. Location of particle. Location of the particle with respect to origin. That simple thing is called by the name position. Okay, this much only. Position means with respect to origin where the particle is located. Let us make it clear with a few examples. So I am writing one example here like this. Imagine like this kind of a scenario. Let us say this is our x-axis and this is our y-axis. The intersection of x-axis and y-axis, that is called by the name origin. I am right only now. Origin don't have any other definition. Intersection of x-axis and y-axis, we call it by the name origin. Now let us say here one particle is located. So let us say here one person is located. Let this be the person. Okay. Now let us say here another person is located. So let this be another person. Maybe a husband and a wife after some quarrel. This be the wife. Both are some distance apart right now. Here this person we call A and this person we call B. Likewise we marked. Since you know the origin, this person A is located at a distance 3 meter from origin, and the lady, the wife, is located, let us say, 4 meter from the origin. Likewise we marked. Now if you are asking me what is the position, what is the position of particle A, what is the position of particle A, which means you need to say only one thing. Particle A is located on where? X-axis. Therefore I can say X coordinate will be 3 plus 3. Y coordinate will be 0. Z coordinate will be 0. When you write like this is called position. Okay, you should not confuse further. This simple thing is called by the name position. But since y equal to 0, z equal to 0, you don't have to mention it every time. So if you want to say what is that person's position, you simply use x equal to 3. That is enough there. Now let us think about the wife. So let us find position of particle B. So I am writing here, you need to find position of particle B. I should know what is the position of particle B. To find the position of particle B, look at there. Wife is standing on where? Negative x-axis. So negative x-axis means x coordinate, you should say minus 4 meters. Similarly, y coordinate will be 0, z coordinate will be 0. See, that's it. So since y coordinate is 0, z coordinate is 0, we don't have to say about them very much. We will focus on x equal to minus 4. So there is x equal to minus 4 here. That is the position of particle B. Understood properly? Now, let us say they have a child, and maybe child located at origin. So this is the boy is located at origin. This time the boy we can call by particle C, child. Then if I write position, I am writing position of particle C. Where is this particle located? Very clearly that particle is located at origin. Therefore I can say x equal to 0, y equal to 0, z equal to 0. All of them are 0 only. Therefore we don't have to mention everything. Depending upon the problem you can mention. Here particle A has position 3, particle B has x equal to minus 4, particle position of child C. We are discussing about particle C, and its position you can say x equal to 0. Here everyone is along x-axis, so y and z don't have that much importance, therefore we can neglect them, no need to consider them. They are present there, but we don't need it, that's it. So this is how position of a particle is mentioned. So I am repeating very simply, position is never a complicated topic, as well as position is never displacement, position is never distance. Distance, displacement, position, all are different quantities. Position means you simply say with respect to origin where the particle located, which means you need to only get what? X coordinate, y coordinate, z coordinate. In this chapter our bodies are either moving in x direction, which means horizontally. Day to day life we are seeing bodies moving horizontally, or bodies will be traveling in vertical direction. If you take a stone, you throw it upward, it is a vertical motion. If you take a stone, drop it from top of a building, it is a vertical motion. So vertical motions are also there. So if the body is behaving, if the body is moving in horizontal direction, positions are denoted by x only. So if the body moves on horizontal direction, if the body moves on horizontal direction, we only need x. Okay, position in that problem I will only write position as x. Meanwhile, if body moves on vertical direction, body is moving on vertical direction, in that problem positions are denoted by y, which means whenever you are dealing with a problem, in that problem they are giving position of a body is y equal to t square. Another problem they given position of a body is x equal to 2t plus 2. I know you are familiar with these two things. In a question they given y equal to t square. From there itself you should understand that body is moving in what direction? The y axis, which means that body is a vertical body, like you are throwing a stone up. That kind of a motion you are studying. So if they give y, no doubt it is a vertical motion problem. It is a vertical motion problem. In one question they given x equal to 2t plus t. They given x equal to. Position is that. Therefore we understood that problem falls in horizontal motion problem. See, if you think in this way, physics become easy. The main issue you are facing with the physics is that you are trying to study something without understanding. If you understand the basics, physics laws are governed by very few fundamental things. Every chapter we have different formulas, but every formula, every problem approach depending not on wide variety. Either we will apply conservation of energy or we will apply V is equal to U plus AT. We have very limited things. With that only every problem I am going to solve. So follow the videos very carefully. Don't skip anything. You watch everything, you study everything properly, so that any question coming to you, you will feel confident. So right now you know what is the meaning of position very clearly. Similar way I will keep one more example like this. Another example. We are again drawing x-axis, y-axis. Every concept should be crystal clear. So this is our x-axis and this is our y-axis. Now what happened means, let us say one body is located here. Let us say this is body A. Position, first position I will put A1, and this distance, okay, this distance they given like somewhat 7 meters. Then this body travels, let us say single person only. That person travels and that person reached here. This is the second position A2. The person's first position A1, the person's second position A2. Then the person traveled again downward. Then the person's third position we put A3. Like this a person traveled. Let us say this distance they provided like 3 meters. And each thing happened at a particular time. Let us say at a time equal to 1, person is at A1 location. At a time equal to 4, the person is at A2 location. At a time equal to 10, the person is at A3 location. One person traveling through the axis. Now we are going to write a position corresponding to each one. So let us write at time equal to 1. Let us write a position as y1. No doubt I won't use x and z because it is what kind of a motion? Vertical motion. Vertical motion means you don't need x and y, x and z, you only need y. So this y, you know the coordinate. It will be plus 7 will be the coordinate. Plus 7 meters, that will be the coordinate. Now at time equal to 4, you tell me now itself. At a time equal to 4, what is the position? Y only, because it is still vertical motion. The body reached A2. A2 is origin. At origin, what is your position? 0. Coordinate only you are writing. Now at time equal to 10, that time if you write y3, understand one thing, position is never distance. It is with respect to origin where the particle. You only need coordinate. So tell me what is that coordinate? Y equal to -3. correct only now. That is your coordinate. Now you understood. As a logical person, you say, what is the distance covered by the man? 7 meter plus 3 meter, 10 meter. But can you see any one coordinate 10 I written? No. That is why position never equal to distance. Position never equal to displacement. Position is position. That only. It simply means coordinates of particle at each moment of time. Time equal to 1, particle was at y equal to 7. Time equal to 4, particle was at y equal to 0. Time equal to 10, particle was at y equal to minus 3. You don't have any other things. This much only you need to understand. Once you are comfortable with the position, let us study frame of reference, which is a very important idea for us. For example, laws of motion, work energy power. These chapters are having very much important things in frame of reference. Many of the students are simply ignoring this, and they will try to study work energy power and the laws of motion, and they will become very much suffocated with the chapters. You study from these chapters are interconnected, so don't try to forget that fact. If interconnected chapters is you are ignoring, it is like you are not studying English alphabets then trying to write an essay. Likewise only it will feel. Chapter should be studied in correct order: straight line, plane, laws of motion, work energy power, rotation. Then only that connection will make sense. Without that, physics will never become easy. Okay, so let us go to the next topic that we are discussing: frame of reference. Frame of reference. What is this thing meaning? It's a very simple idea. Frame of reference means where origin is located. Where origin is located. Where you are going to decide your origin. That is called a frame of reference. Okay. Now, let us see what is this meaning. Every time understand, origin means we will imagine. At origin, always there will be a imaginary observer present. Imaginary observer present. This is a simple logic. I know you people know physics from even 9th standard or 10th standard. Maybe you will be a repeating student or 11th, 12th studying. One problem in physics, let me say. A car is traveling with a speed 20 km per hour. Okay, the question will begin like this. Let me ask you, in question they said, car is traveling with 20 km per hour. Who is giving that data? Who is telling you that question? You may think it is the teacher putting question paper. You may think it is the board exam conducting. No. In physics, that question is given by an imaginary observer. There is a person. That person seen car is moving with 20 km per hour. And that person informed your teacher. And then teacher put it like a question. You need to think like this. I know it sounds crazy, but this is what happening. There is an observer. It is not a teacher. It is not a board. They are asking. That question is given by an observer. There is a person seeing something. He is giving you data. You need to think every problem like that. The question is, where is this observer? This observer will be always located at the origin. For one moment, let me go back to this topic. Okay. So you are writing time equal to 1, y1 equal to 7. Who observe these things? I given no 7 meter away, 3 meter away. Who given you 7 meter away, 3 meter away? It is the observer. There is a imaginary person standing at origin. This person is giving you data. A1 is 7 meter away. A3 is 3 meter away. A2 is at origin itself. He given the data. That is what wrong. Then he asked you, find the position. So the person giving you data is the observer. And you need to do the problem. It is like input he will give, output we need to derive, we need to find using the formulas. So here in this question, okay, this question you can imagine even child is the observer. Child is located at where? Origin. So we can say like child looked, my father is 3 meter away, my mother is 4 meter away. Instead of solving, you help me and come solve it. He given you what? He asked position. Okay, maybe child will be little physics interested child. That is why this happened. He is standing at origin. He said my father is 3 meter away. He said my mother is 4 meter away. And now he is asking you find the position of my father, that is A. Find the position of my mother, that he won't say, that you need to do. So in this problem, child is your observer. Understand, in every problem the data is given or the question is provided by an observer. That is your idea. Question is provided by an observer and observer is standing on where? Origin. This is what you right now know. So let us go back to our topic. Frame of reference. It is where origin is located. At origin, always understand there will be an imaginary observer present. Now let us see one idea to understand this. Let us say this is a road. One road is like this. In this road, one person is standing. Let us say here one person standing. And there is a bus. Let us think about one bus like this. And bus is moving away. This is our bus. Let bus be moving with some speed like this. Inside the bus, another person. Think about another person. And in this bus, maybe at this location, there is a block present. Like this. One block is present. Call this one by the name A. This one by the name B. Okay. And this block maybe we say C. This is what happened. Now let us understand what is happening here. There are two observers, observer A, observer B. In a problem, never take two observers. You need to only take one observer, complete the question. So here what I am going to do, think about observer A. So I am going to write with respect to observer A. This is what I am going to write first. With respect to observer A, never think about observer B. A will be observing that block C. This is what going to happen. Now let us mark a distance between these two. Understand, distance between these two. Likewise. And this distance, let us say some 20 meter away. Now let me ask you, at this given moment, A is the observer. Wherever observer standing, there you need to imagine this is your origin. Okay, observer will be at origin only. Now can I say what is the position of C? I will definitely write X, correct? Because I know it is a horizontal motion. So you need to write X only. With respect to that origin, how much distance? 20 meter. On which side? Positive side. So I can say X will be plus 20. I think everyone agree on that. X is plus 20. But the bus is moving. But person A is not moving. A will stay there only. Bus is moving away. So the next moment this position X value will become plus 21 maybe. Next moment bus is moving away. X will go to plus 22. Likewise, position will change. This change in position happened, then we will say the body C is in motion. Body C is in motion. But one more thing you should say, it is with respect to which observer? A. That is the importance. A is looking at C, then with A will feel C is moving away, it is already in motion. This is what in physics we call it by the name motion. Motion means we are indirectly saying which quantity will be changing? Position. See, this is the fundamental. If you don't know position, how you know a body is in motion? Logically thinking will not work here. You should know the correct definition in physics what we are meaning. So it is simply motion means always remember position changes. Position changing is called by the name motion in physics. And where this observer A is standing, look at there. In the diagram where the observer stands, he is standing on ground only, no? Therefore, you say ground frame only we done the problem. So there is nothing complicated here. The problem is done in ground frame. Frame of reference is ground. So I am repeating, there are two observer A and B. I ignored B. I think I am A. Then with respect to observer A, where A is standing? Ground. Then you say I am doing the problem with respect to ground, frame of reference of ground. Then I see position of C. It is continuously changing 20 to 21, 21 to 22, 22 to 23. Therefore position changes. Then you call by what name? Motion. I'll say body C is in motion. This is what happened. Now let us do this problem with respect to B. So I am going to write with respect to observer B. With respect to observer B. Observer B means no need to take origin here. And we are going to take observer standing is your origin. Therefore, here onwards let us say this is your origin. Origin is where observer B is standing. That is your origin. And with respect to this observer, that block, let us say with respect to this observer, this block is somewhat 5 meters away. Okay. Now tell me very clearly where observer B is standing? On bus. Then this problem is done using frame of reference of bus. So understand properly. Observer B is standing on bus. So we are doing the problem on bus frame. That's it. Frame of reference is bus. Wherever observer standing, that is your frame of reference. Don't think too much. That's it. Now for him I will also write x equal to, look at there, with respect to B, C is at, tell me the coordinate of C with respect to B. I will say x equal to plus 5. Correct only, you know. Suppose if you wait 1 minute, after that also if you look there, what is distance from B to C? Again 5 meter only. So with respect to B, that position will remain 5 meter. So this is again 5 meter. Again I waited 1 hour. Then also I am looking with respect to B, that C block will be at again plus 5 meter. Correct only, no? Therefore I can say now body C is at rest. Body C is at rest. But remember, with respect to whom? With respect to whom? With respect to B. That is the most important thing. If a body is at rest, we can only say with respect to B. And rest means, now you know the definition. Rest means what? Position should never change. That is called a rest. So position doesn't change. no change in position, and that simple idea we call it by the name rest. So now you know whatever we studied very well. So I am repeating that thing in a very 1 minute recap. Think properly, understand properly. Here, position. Position means simply coordinates: x coordinate, y coordinate, z coordinate. But we never used to write all the coordinate. Whichever required only we will write. In this problem you can see, if you know the origin, a will be x equal to 3, b will be x equal to -4. That's it. Therefore you understood very well. Position can be positive, position can be negative, position can be what? 0. A simple theory. Position can be positive, negative, 0. Three things are possible. As usual, whenever a body moves horizontal, we will put x equal to. If a body moves vertical, we will put y equal to. So in any problem you see y equal to, understand it is a vertical motion. Any problem you see x equal to, understand it is a horizontal motion. Similarly, when a body moves, positions will change continuously. At each time interval I return positions. Position is never displacement, distance. Position is position. And once you know what is a position, we can start with the frame of reference. What is frame of reference? Wherever the observer located, there is an imaginary observer present at origin. That observer is giving you the problem. Think like that. Observer is giving you the problem. An observer is located at origin. Observer can be in two type of idea. Suppose observer standing on ground, we say we are doing problems in ground frame. Observer standing on bus, we say we are doing problems on bus frame. Now you look at both of them carefully. With respect to ground, body C is in motion. With respect to bus, body C is at rest. Due to this only we say there is nothing in this world like absolute rest, absolute motion. What is the meaning of this absolute? Absolute means very simple. Everyone agreeing on something, then we say that is absolute. But some people are conflicted. For example, I am saying like in Tamil Nadu, the most best actor you can see in the industry is Vijay. If I take a classroom full of 100 people, then I said Vijay is the best actor. Then okay, if entire 100 is agreeing, we say it is absolute. But instead of that said 80 said this much, or remaining 20 said no, this actor are the, which means there is a conflict. That is called relativity, which means some persons agreed, some persons never agreed. Then we can never say it by the name absolute. Look at about block C. Those who are outside the bus will say block C is in motion. Those who are inside the bus will say block C at rest. Therefore there is a conflict. That is the reason in NCERT and all they written that word rest and motion are never absolute. Rest and motion are never absolute. Nobody will agree. Suppose now I am sitting in front of a laptop, you are sitting in front of a laptop. Now your mother coming, mother will agree you are at rest. But any person on outer earth will see us rotating along with earth. So we don't know whether we are at rest or motion. It is purely what relative. Who is looking? That is the most important thing. So rest and motion are not absolute. Well, remember, rest and motion are relative. Rest and motion are relative in nature. That you should understand. Okay, so I think everyone understood up to here. I am repeating, don't skip any. We have a tendency to skip it and go. That kind of things will never work. We will miss an important point. Right now I am going to say some important point. If you follow up to here, okay, you are going to get it. Others are going to get confused. You are having two observers, A and B. See, So which observer we should choose for doing a problem? Understand, in physics 90% of the problems we are doing using observer A, which means if you write F equal to ma, if you write momentum conservation, if you write angular momentum conservation, all these things are only work with observer A. So many students don't know this thing. Okay, they think anywhere we can write. It is not like that. Momentum conservation, Newton's law, work energy theorem, these kind of things will only work with observer A. You study like that. Okay, don't think about observer B until they say in the question. So that type of questions also we'll study. It will come only in laws of motion chapter. So right now don't think about it. Here onwards in every class our observer will be standing on where? Ground. We won't say it every time. We will take like that only. We will do the problems completely. And last point I am need to add is that I am teaching this for you to crack NEET or JEE mains or JEE advanced. That step also will be taken. I want you to understand. Therefore I will be using some vague explanation. I will be never saying things what I say will be perfect and all. So it is not like the not this not that. Right now I want you to understand what is position, what is frame of reference. In coming chapter I will modify. I am teaching this for students, those who want to understand and love physics. So there will be some points. I feel one point, it may be feel a little wrong, but it is make you to better understand. So you trust on me on that thing. Don't trust on others. But they are going to point out this is wrong, this is right. It is not like that. You check whether you are able to understand. Then you continue watching. Okay. So next class we are going to upload distance and displacement. Feels like a very simple topic, but understand JEE mains. There are repeated questions from distance and displacement. So it is never a unimportant topic. Every topic is important. Hope everyone understood the class. Your valuable feedbacks are very important to me. So any improvisation, anything you require to add, these kind of things, please comment. Thank you everyone.